Hey, I'm Melissa,
I'm Jam.
and I'm a chemist,
And I'm not.
and welcome to Chemistry for Your Life.
The podcast helps you understand the chemistry of your everyday life.
Okay, Jim, today's episode, I'm really excited. I guess I'm always excited, but it's inspired by my friend David.
Okay.
But before we get to the episode, I do want to take a minute to shout out our new Patreon supporters. Yay!
That's right. Since our last, real proper episode, we've had 4 new people join our awesome team / community of patrons over on patreon.com/chem4yourlife. And those people are Nicole C., Emerson W., someone named Shadow.
This is so mysterious and cool.
Yes, very cool. And Brian K. Guys, thank y'all so much for supporting the show, for keeping it going, keeping it free, and just caring about sharing chemistry with a lot of people around the world.
It means so much to us. And coming up this week, we're going to have our first ever coffee hour with our H-Bond tier. So that's really exciting. And our sticker that we'll be sending out to some of our supporters based on the tiers just came in the mail. It's exclusive to those supporters, and I'm really excited. It's so cute. Work by local artists. So it's been really fun to start connecting with our Patreon supporters. Okay, so that's been really fun, but also really fun is today's episode topic.
Nice.
So again, this episode is inspired by my friend David. He is in the same research group where I did my PhD research. And we were just walking and talking one day about how candles burn. And he said, "No spoilers, I'm listening in order." Which made me laugh, like something that happens in our life could be a spoiler.
Right. That is so funny.
I was like, I don't know that candles burning is a spoiler, but okay. But then he said that he wanted to know how trick candles might work. He thought that might be an interesting topic.
Okay, trick candles.
Yeah, do you know what trick candles are?
I feel like is it the ones that won't go out?
Yeah, well, they'll go out, but then they come back.
Right. Yes.
So they're sometimes called relight candles. Sometimes they're called magic candles. Funnily enough, they're banned in Canada, which I think is amazing.
Weird. I mean, I guess maybe it'll make sense once you explain it, but that seems so strange to ban it.
Well, it's because they're prone to reignite spontaneously. So if
Right.
you didn't remember that they were magic candles, or if, you thought they were out and they weren't, and you threw it in the trash, it could light your whole trash can on fire.
Right. Or other explanation, just hypothetically, maybe a certain politician didn't like the trick being played on them in Canada. And they were like, you know what? Nope. No one is going to go through this again like I did.
That's funny.
Just not a good sense of humor, so he banned them.
Maybe so. Well, I've had those for my birthday in 2020. I remember my sweet roommate, Nicole. It was right when COVID was starting, and we weren't sure what was happening.
Oh, yeah.
And I was supposed to get together with a bunch of friends at like a local drink place called Harvest House here. And I was like, I don't know, maybe we shouldn't. So I canceled that gathering, and it was when my mom was sick and I was sad.
Yeah.
And I came home, and Nicole had like a feather boa for me and a crown, and she had like a little cake and some magic candles that I didn't know were magic candles. So I blew them out, and they came back, and it's like, it's always so delightful and shocking. But then you're like, how do you get these out? And I remember us being a little scared because we would blow them out and then to take them out of the cake, but they could reignite at any minute. So it was kind of scary. So that was fun.
Yeah.
So, and I remember wondering that night how they work.
Yeah.
But I didn't have the capacity to go look it up. So here we are today because of David.
Yes. Just
So
a few
thanks,
years
David.
later.
Yeah.
Yeah.
I think it's more than 2.5 years later, actually.
Man,
time flies when you're in a global pandemic.
Yeah. Amen.
So we already did an episode on how candles burn. Do you remember that?
I do. And I actually feel like I kind of remember it better than some. There's some episodes that we do, depending on how hard they are for me to understand or whatever.
Yeah.
Where like the more weeks go by, the more it fades.
And maybe the less you encounter it in real life.
Correct. But we do somewhat regularly burn candles around here.
Especially in the fall.
Yep, 100%. So my wife really likes them, and I do too. I mean, especially if I've just cooked something that smells strongly and I want to like cover it up with something else, then I light a candle. But I feel like because of that, it's been a little bit easier for me to remember the basics of candles.
Okay, so do you want to take a stab at teaching me about candles, doing a quick reminder for me and the listeners?
Yes, I'll try. I'll try to do it quickly, and I'll stumble through it, but we'll see what happens. So I remember it being that the heat at the top,
Yes.
when you light the wick, is as that is lit, because it's lit, it's drawing wax. It'll continue to draw wax up the wick.
Mm-hmm.
It burns the wax, and that combustion's happening up there
Yes.
is what keeps drawing more and more wax up the wick, basically.
Yes.
That's why the wick seems like it's not like just burning itself like in like a minute. You know what I mean?
Yeah.
And that's, I think, the basics that I can remember.
Yes.
There's probably a lot more, but
no, that's good. So the wick it's burning, but it's not the main source of like fuel for the candle. So we light the wick and it melts the wax, and when the wax is in liquid, it can be drawn up into the wick through that capillary action thing we talked about.
Yes.
Where basically, the liquid travels up and it gets vaporized, and then the vapors of the wax is actually what's doing the combustion reaction.
Right.
And remember we talked about how the reaction sort of needs something to get it over that initial energy. Like it needs a little bit of energy, but then once it starts, it's giving off enough energy to keep it going. So it's almost like the lighting of the wick pushes like a boulder down the hill, and then it just keeps going. It's like a self-fueling reaction, kind of.
Because there's all this fuel right there, but it's in a state that at the moment is not usable until it's melted.
Yeah, it needs some energy to get the reaction going. And then once the reaction is going, it gives off energy in the form of heat and light, which is a candle burning.
Right.
Which is great.
Yeah, and it smells great.
And it smells so good. There's this one candle I love that's called Volcano. It's by Capri Blue.
Whoa, that sounds cool.
It's super expensive. It does not smell what I think a volcano would smell like at all. I imagine a volcano would kind of smell like sulfur, but it is my favorite candle in the world. So.
Interesting. Is it kind of like cologne-y a little bit?
No, it kind of smells like sweet to me.
Okay. Interesting. I feel like
fruit.
I can see someone using the word volcano for like almost like a cologne-y type of scent.
Yeah.
You know what I mean? Not that that's exclusive to men, but all like, for instance, my wife prefers candles that have a little bit of like a cologne-ness.
Yeah, like
to them.
cozy sweater or whatever.
Right.
Yes.
Right. That aren't too. Yeah. Anyway. But
no, I actually don't know that your wife will love this candle too much.
Okay.
It's much more fruity and less fall-y. It almost smells like spring to me.
Okay. Interesting.
Okay. So sorry, that was an aside about candle preferences. Yeah. But if you ever see it, it's like at little boutiques and stuff usually. And weirdly at Buc-ee's, which is a Texas gas station that has all kinds of stuff. Buc-ee's has it too.
Interesting.
I know, weird. But it's a good gift candle, I would say. So that's an aside on regular candles and how they work and which one I think you should buy. Okay. So the vaporized wax is the fuel for the candle. Mm-hmm. And that's how we did that trick. We did an episode where you can, an experiment at home where you can use a lighter above a candle that's burned out and get some of the smoke from the candle to light on fire, and the fire will travel down back to the wick and reignite the candle.
That's right.
Okay. So trick candles are not so different than that. But can you think of something that would maybe make them work? It's okay if you can't. I just figured I'd let you try. And maybe our listeners at home can think about it too. My husband came up with it really quickly, and I was
dang it.
Like, oh, rats, how'd you get that?
Yeah.
So I wanted to give our listeners a chance too, in case they, like him, could have the satisfaction of guessing right.
Well, it's probably in some ways better for the episode that I can't really come up with anything specific. Like, all I can think of is, could they mix something in there that also burns in a different way than a standard candle? But I can't think of what might be a way that it could be delayed. You know what I mean? Like
that's actually really good. The idea of mixing something in there.
Okay.
That can burn.
Okay.
That's basically it. So basically there's something in the candle extra that's not usually there that can act as a source of ignition to push the boulder down the hill again, basically.
Okay.
Something that can get the self-contained reaction to keep going, you know?
Right. And as we've seen in like when we did that experiment, it doesn't take, once it's already been lit once, it doesn't take a lot because there's still the stuff right there.
Yeah.
There's still some vapor
There's
right
still
there.
vapor right there, so it's ready to relight. So basically, just like in that smoke trick, you just need something to catch it on fire again. Just like a quick something to get the reaction rolling again.
Okay.
So I didn't have a guess of what that was. I had to look it up.
Okay.
But what that thing is magnesium.
Okay.
So they mix magnesium into the wick because magnesium is a combustible metal and it ignites at relatively low temperatures for metal.
Okay.
So, I mean, you've probably heard of magnesium a lot, actually. It's usually a salt that we encounter. So have you had like an Epsom salt bath?
Yes, I have.
That's magnesium sulfate.
Okay.
So in the same way, sodium is a metal, but then we have it in salt form in sodium chloride. Magnesium is a metal, but when, it forms ions and mixes with other things, it comes in this salt form, like Epsom salts.
Uh-huh.
So there's also metal alloys of that of magnesium where it's basically incorporated in with other metals. So I know that magnesium alloys are used for things that should be lightweight, like bikes and car seats. But when magnesium is ground into especially fine particles, so the smaller particle size, the easier it can be, those can ignite very easily.
Mm.
So when it's in its pure form, not in the alloys, not in the salt, and in small powder, if there is enough heat, then that will cause the magnesium to ignite.
Dang, interesting.
So it has to be relatively hot compared to room temperature to burn,
Yeah.
I'm like, oh, it burns at relatively low temperatures. That's for metal.
Yeah.
It's not like it'll be a hot day outside and your trick candles will just like ignite. It's not like that. So this is another question I have for you. I'm kind of putting you on the spot today because I think this is a good episode to have us test out our knowledge a little bit.
Okay. Deal.
But how hot do you think candles burn that they can ignite magnesium?
Ooh, wow. Okay.
I don't know if we actually talked about the temperature of candles in our last episode or not. I couldn't remember.
Yeah.
But since I can remember, I thought you might not remember either. So
Okay. Here's the way I'm thinking about it based on being a normal person, a lay person.
Uh-huh.
Okay. I'm thinking about metals that I do experience and what heat I see them around. So for instance, it seems like if it's a relatively low combustion point or whatever,
Yeah.
then some of the metals I use to cook things with or whatever must have much higher, or at least a little bit higher.
Yeah.
Right?
Because they're not combusting.
They're not combusting when I have them in the oven at 400 or whatever. So, I don't know, paper burns at 451. We all know that from the book title.
I did not think, I have not thought about that for a very long time. So we didn't all know that.
Okay, well.
I mean, when you said that, it reminded me of something, way back in my brain. But
what if it was somewhere in the 300s?
Okay, it's way more than that.
Dang
Isn't
it, really?
that wild?
What the heck?
So it is, candles can burn up to 1400 degrees Celsius.
Holy.
Which that's 2500 degrees Fahrenheit.
So it's just, wow.
It doesn't seem that hot to me.
The fact that it's this tiny flame means probably the point of that level of heat is right in the middle or something. But
yeah.
That's crazy.
So it's hot enough after you blow the candle out still that the magnesium can combust.
Wow. Okay, that makes sense then. Yep.
And the magnesium is combusting even while the candle is burning. If you've seen a trick candle, which I don't know if everyone, has because they are banned in some places.
Yeah.
But while they're burning, they're sparklier than regular candles.
Right.
That is the magnesium combusting as well. It has a kind of a different quality.
Got it.
So, but after you blow it out, it's hot enough, even when there's no flames left on that candle wick, to reignite by making the magnesium combust.
That is so crazy.
I know. Isn't that wild?
Yeah, seriously.
And I think it's the smaller the particle size to a specific extent, because it gives higher surface area. So it's more places for the magnesium atoms to react.
Uh-huh.
But the smaller particle sizes will affect how easily it can combust and at what temperature. But it can ignite as low as 450 degrees Celsius, which is close to like 850 degrees Fahrenheit.
Okay.
So basically, it can ignite as low as the high 800. So still higher probably than your oven will reasonably get.
Right. And I guess one of the flaws of my approach to that was like knowing that the metals I use to cook with don't combust at that level, but not knowing what they combust at.
Really high.
Yeah.
I mean, I think a lot of
cast iron can go, in the oven at like the highest your oven can go, and it's fine.
Yeah.
So it's like, but it doesn't tell me much because I don't know at what point would it have a problem, and then with magnesium, how much lower would that be? So
well, and I was a little confused on this, and I think this is an area that probably an inorganic chemist who focuses on more metal type things would know. But at some point, most metals just melt.
Oh,
so the fact that it ignites, I was like, well, why is it igniting instead of melting? And I didn't get a lot of good insight into that. So maybe someone who listens who's an inorganic chemist could tell me, and maybe it's something really simple that I'm just not thinking of. But I thought, why is it igniting instead of melting?
Yeah.
But also some things just have different properties like that. Some things just will degrade, like salt usually degrades instead of melting because the bonds are so close together. It's really hard to turn it into a liquid,
Uh-huh.
And so they're just different things have different properties. So I don't know why magnesium ignites instead of melts, but it does.
Mm-hmm.
And it does that at a relatively low temperature for metal, which I didn't think about how hot that candle would be.
Seriously.
It just seems like that's really hot. And birthday candles might be on the lower range of that.
Yeah.
But that was just a paper I found that generalized sort of the properties of candles. So I thought that was really interesting.
Yeah, that's crazy.
So the way the trick or magic or relight candles, whatever you want to call them, works is essentially that when you blow out the candle, the heat doesn't go away immediately. And if there is enough heat, the magnesium reignites. It will just ignite itself basically with that heat. The heat is enough to start the reaction with the magnesium. And that ignition of magnesium gives off enough energy that it's going to cause the vapor of the candle that's still hanging around to react with the oxygen, and boom, there we go. We have our self-contained candle burning going again.
Yeah.
And also magnesium, because it gives off a lot of energy, it's often used in like emergency flares. So there's times where people will have to send up flares if they're lost in the woods or, things like that.
Right.
A lot of times they'll use magnesium for that because it burns really brightly. And that's why those trick candles have kind of a different color quality almost.
Oh, I see.
Yeah. So it's not just using candles, but it is used for our fun birthday party trick candle.
Yeah.
Isn't that so fun?
Yeah. Seriously.
I was very excited. It seems so simple, right? It's like, oh, you just add something in that can use the heat that's left behind to start the reaction going again.
Yeah.
So I will say they're dangerous because they can spontaneously relight with temperatures as low as, in the 800s, which if we're up in the 2500s and we're Fahrenheit and we need to get below that threshold, I could see how someone would think, oh, it's done reigniting. And then
throw the trash can or something.
Yes.
Reignites.
So I looked up some of the safety precautions and they recommend, I think there's like an American Candle Association, which I didn't know.
Mm-hmm.
They recommend that you put the candles in water for an hour or so to make sure that there's absolutely no way that it could reignite before throwing them away.
Yeah. Dang.
So that's how they work.
That's crazy.
Do you want to take a chance at saying it back to me?
Yes, I'd love to. So here's an analogy that came to mind for me.
Okay.
Off of the theme of these being used at parties or whatever. So imagine that you have a party going and there's dancing. Everyone's having a great time. Imagine like specifically kind of like those dance music kind of scenes or whatever.
Like a rave type situation?
Rave, yeah. Anything where, music is loud and is fueling the party.
Lots of lights flashing, people having a great time.
A great time. And then someone pulls the plug on the music. If you have some people in the crowd who are they're still really wanting to dance.
Yeah.
They're still committed. The longer, though, the music's gone, the chances of the party starting back again.
Yeah, people are kind of like, well, there's no music. I'm going to go somewhere else.
Yeah, let's get out of here. Let's go do something else. But if even just a little bit of music can get going again, the people who are really committed, who are really ready, they don't require much. They'll start dancing again, and it starts the whole party again. You know what I mean?
Okay, yes.
There's enough momentum. If you get about, say, you've got a room full of people, and about 15 of them or something start dancing like crazy.
Yeah.
It's hard to ignore, and it's going to start something. It's going to start a dance party again.
I thought you were going to go somewhere totally different with that. I thought you were going to be like, and if you have just one person in there who's a technician who can figure out the problem. That's what I thought you were going to say.
I was thinking about like, we're all burning, like the wick and all the things that are going on in there are all burning. But the magnesium will be those like, we're ready to party. We want to party again.
Yes.
As soon as there's a little bit of a sign, a little bit of some party essence, we'll party again, and we'll get the whole thing going.
And then they'll make it fun for everyone else too.
Yep.
Yeah.
So back to the real thing though, it's that the candle gets blown out.
Yes.
It's still super hot though.
Yeah. Ready to party, primed for the pump.
Still lots of potential there. Still lots of energy potential. And so and
there's still wax vapor hanging out around it.
Wax vapor and magnesium right there, ready to combust.
Mm-hmm.
So it may, to our eyes, appear as if everything has stopped.
Yes.
But really, there's still a lot going on. There's still enough heat that the magnesium could, after just a couple seconds of us seeing no flame, could combust.
Yes.
And start the whole party over again.
Yes.
And everything gets lit again, and the candle's burning, and it all goes back to normal.
Yes.
In this like steady flow of energy being produced or being given off and burned and drawn up and all that stuff. The whole chain reaction continues again, as long as that can happen.
Yes.
And it's because it can combust at such a low temperature relative to not only other metals, but also just the temperatures of the candle.
Yeah. Yeah.
Like it's a lot lower than what the candle's even burning at normally.
Because the candle can burn around 2,500 degrees Fahrenheit, but the magnesium can ignite around 850 Fahrenheit, as low as that, depending on the particle size and the conditions.
So is that it?
That's it. You got it.
Nice.
Yes, I really thought that this was a fun one. It was kind of quick, but it was something that I had wondered about, and clearly other people wondered about too. So I thought that was really fun.
Yeah.
And it's a fun part 2 to our candle adventure.
Yes.
Which I didn't even know how candles worked when this whole episode situation started. So.
Yeah. Seriously.
Awesome. Well, that was really fun. Maybe if I remember, I'm notoriously bad about saying I'm going to post that and totally forgetting.
Yeah.
But if I can go back and find that video of the trick candle scaring me, I will definitely post them, because I think that's a fun memory that I have of like a really special night.
Yeah.
So, and speaking of fun things, Jam, do you have anything fun to report for this week?
So I've got kind of 2 things in mind. One is like not necessarily fun, but just an update.
Yeah.
That's significant enough. You know what I mean? And then the other is a little bit of a fun thing. So about a week ago from recording this, my wife went back to work. She'd been on maternity leave from having our second kiddo. And so she went back to work, which is tough. She works 3 days a week. She works in medicine. So I got back into the swing of watching the boys.
Yeah.
But it's different because last time I was doing that with this specific schedule to it, there was only one kid to watch.
Right. And now there's 2.
Yeah. So that's been pretty different this week. And it's taking me a bit to get back into the habit of that. And also just.
And one that requires a lot more attention than the other now.
Yep.
Like the older boy he's kind of self-contained to some degree now.
Yeah. Yeah.
But like, the younger one requires a lot.
Yes. But they sometimes, you can play your cards right where their times of needing very specific attention can be alternated.
Yes.
So if I 2 out of the 3 nights last week, I nailed that.
Nice.
One of the times some curveballs happened.
I feel like I'm winning as a dad.
Yeah. But one of the times it didn't work out great. It was like, one of them really I had one in the bath while I was trying to feed the other one.
Oh gosh.
And then I was trying to put one to bed so I could get the other one finished. And anyway,
Yeah.
It didn't work great that night, but the other ones it has. And so that's been interesting. It's been strange. And I forget also just like how watching both the kids alone for 12 hours straight, and that's not really 12 hours straight because they go to bed at some point, but
right.
I'm the only one watching them for a 12-hour chunk while my wife's working, how exhausting that can be.
Yeah.
Since Em's been on maternity leave, we've had a lot more watching them together or watching in smaller chunks or whatever.
Right,
We
definitely.
haven't had to do like and even when I'm working, I'm not gone for like 12 hours straight. I come back and
eat lunch
and
then head back out. Yeah.
stuff like that. So it's pretty different. But so that's been new.
Right.
But it's been going fine.
Less of a fun thing, kind of just like a life update thing.
Yes, exactly. One thing I've been doing though, in the midst of that, is I've been trying not to watch very much TV lately.
Mhm.
I've made the rule for myself that I only watch shows with people.
Yep.
And then it's kind of a group.
Are you about
thing.
to tell me that you've been watching the Lord of the Rings show without us?
Nope, I have not
Okay,
done
good.
that. I have not betrayed you guys. But one of the things that I remember now that I'm watching the kids 3 days a week is that I am completely toast after I've been watching them.
Yes.
I don't have a lot of energy after they go to bed, but I may not quite myself be like immediately able to fall asleep.
Yeah, you need to wind down.
Yeah. So what I did is I let myself, instead of watching a new show, I let myself watch a show that I have already seen.
Is it Seinfeld?
It is not Seinfeld.
Oh, House.
It is a different one that we have history with. It is Twin Peaks.
Oh, that's a good one, but kind of spooky. So good for spooky season.
Good for spooky season.
Wow.
I haven't rewatched it in a while. I think I've watched the whole thing twice before.
Nice. The first 2 seasons are really right up my alley, quite my jam. But then after that, it's a little too much for me.
Which, like, I think the third season doesn't even have like a ton of episodes anyway. So the larger percentage of the show's just existence is just season 1 or 2.
They just have like a good spooky vibe. To this day, when I'm out at night and the trees are rustling, I get like a little spooked out, and I think it's because of that show.
Yeah. So I've been really enjoying that, and I'll like put it on, and I don't feel like I have to pay solid attention to it, so I can like put it on, pick up the toys the kids got out, do some dishes, that kind of stuff. But it's nice because if I was to try to do something else, like something work related, or listen to an audiobook that I've been trying to like get through, something like that.
Yeah.
All those things require more mental capacity than I usually have. And so I was like, this fits right into that little gap.
Yes.
Without,
kind of a comfort show.
Yes.
Yeah.
Without getting hooked on a new show, which is what I'm trying to avoid. So anyway, that's my stuff.
That's a good one. That it is. I feel like having a show like that's almost like an old friend. You're like, I know exactly what's going to happen in this episode, so I can walk out of the room while it's on, and I'll know what's going to come on when I'm back, and it'll be funny and fun, and just like keeps me company when the house is empty and it's quiet.
Yep.
And
Yep.
There's good shows like that. I'll talk more about this in our next episode, but I was out of town recently, and I one night was having I was feeling kind of lonely, and I was texting your wife, and I was like, I'm just going to watch Murder, She Wrote and eat my hamburger and go to bed early. And she was like, that sounds like a dream. So we kind of she and I share those kinds of comfort shows.
Yeah.
That's funny.
That's great.
Oh, well, I love that. That's really good. What I'm going to talk about is actually totally different.
Okay.
But speaking of little kids, I guess.
There you go.
We took our 4-year-old nephew to Six Flags. I'd mentioned we were going to maybe do that. It was better than you could have ever dreamed. He had the time of his life. So it happened to line up with my husband having like a family to bring your family to work day. So we went to that, and there was like prizes and candy, and my nephew Edison had the best time. He was just like, this is amazing. I love Mason works where there's like big trucks. And so he's like, I love these big trucks, Yeah. Like every little kid's dream. And then we went from there to Six Flags. Okay. So one big, exciting, tiring event to another.
Yes.
And he rode his first little kid roller coaster. And Mason got a really good video of him when he came off of it, like a subtle one where he didn't know he was being recorded. And Mason was like, how'd you like it? And he said, it was crazy. It went this way and went that way. I love roller coasters. It was so cute. Aww. And he played a game and won a prize because in the little kid area, like everybody wins a prize. You know?
Yeah.
It was just really fun. And then he came home and slept. He slept so hard. He fell asleep in the car on the way home. He slept through us getting dinner. Like we drove through a McDonald's. We stopped at a restaurant and like Mason went in and got us food. Then we got home and we woke him up when we got home and he fell back asleep before we could get him out of the car seat. I mean, he was wiped out.
Yeah.
And then we gave him his little Happy Meal and then he fell asleep like on the couch just where he was sitting.
Wow.
And he slept for a while. So we tired him out, but he had the best, most exciting time. I was like, this is so fun that we got to be a part of that.
Yeah, that's so cool.
And Mason has like his grandmother remarried to someone when she was, he was still pretty young. And so he had taken Mason to ride roller coasters when Mason was little.
Oh, that's cool.
So Mason sent him the video and his grandfather responded and said, nice, you're going to have a roller coaster riding buddy for years to come.
Nice.
And I was like, oh, that's kind of cute. Like the cycle
that is cute.
Sort of repeats. So yeah, it was really fun. And I was really excited to get to be a part of that and see him have such a great day. And, all like those things are just more fun with a kid to have their mind blown by it, you know?
Yeah.
So.
Yeah, 100%.
That was a really fun time. And then, unlike you with your kids, he went home and we slept for 12 hours.
Yeah,
we were as tired as he was.
Yep.
So that was really, really good.
That's so fun. Very cool.
Yes, I loved it. He's a really cute kid and it was really enjoyable. So, well, thanks to Mason's grandfather for giving us the idea to go to Six Flags, and thanks to you, Jam, for being so excited and having a fun time. And
anytime.
Thanks for learning about candles, magic candles. I was really excited to do this episode, and I was really excited to share with our listeners.
Well, thanks for teaching us. Super cool, very interesting. Haven't thought about those candles in a long time, but of course, when I did encounter them, never knew how they work. So thanks for teaching us about those. Melissa and I have a lot of ideas for topics of chemistry in everyday life, but we do want to hear from you guys. So if you have questions or ideas, you can actually reach out to us on our new website, chemforyourlife.com. And you can go to our contact page and submit your question or your idea or a follow-up or a correction if you have one. So you can go do that on there. It's a little easier for us to sort through. So doing that there, instead of having it come through Gmail or Twitter or Instagram or Facebook, you can understand how it makes life easier for us. So
definitely.
chemforyourlife.com. That's chem, F-O-R, yourlife.com to share your thoughts and ideas. If you'd like to help us keep our show going and contribute to cover the cost of making it, go to patreon.com/chemforyourlife or tap the link in our show notes to join our super cool community of patrons. If you're not able to join that, you can still help us by subscribing on your favorite podcast app and rating and writing a review on Apple Podcasts. That also helps us to share chemistry with even more people.
This episode of Chemistry for Your Life was created by Melissa Collini and Jam Robinson. Jam Robinson is our producer, and this episode was made possible by our financial supporters over on Patreon. It means so much to us that you're willing to help us make chemistry accessible to even more people. Those supporters are Nicole C., Timothy P., Bree M., Chris and Claire S., Hunter R., Stephen B., Avishai B., Chelsea B., Christina G., Emerson W., Shadow, and Brian K. Thank you again so much for everything you do to make Chemistry for Your Life happen.
We'd also like to give a special thanks to S. Navarro, who reviewed this episode. And if you'd like to learn more about today's chemistry lesson, check out the references for this episode in our show notes or on our website.